Hi, welcome to part 3 of programming for psychologists. First, a little recap. So, let's first do a recap of matrices and vectors. Vectors are one-dimensional matrices, and you can define them in MATLAB by just typing the values and when typing the values, put them between square brackets. If you do that, you get a row vector. A row vector is a vector where the numbers are aligned horizontally, so in a row. You could also, instead of putting spaces between the numbers, put commas between the numbers. You get exactly the same result. A slightly different result is when you put semicolons between the numbers, because then the semicolons, they end the line, so you get a column vector. Column vector, you can see the subtle difference between what a column vector is and a row vector here. It's simple. You can also define a matrix like this by combining either the commas or the spaces with the semicolons, just like this. I will show you what happens when you put semicolons in the lines. You get a matrix. In this case, a 4 columns, 3 row matrix. But we all did this before, so we know what happens. So let's go back to putting my number just into a simple vector with numbers 1 to 4. So doing that, you can specify it like we did before with 1, 2, 3, and 4. But you can also say to MATLAB, give me numbers 1 up to 4 by typing 1, colon, and then 4. So the begin and the end. And even you can change that by saying 1 to 40, and you get 40 numbers, and you can say 1 to 40 in steps of 4, and that will give you all the numbers between 1 and 40 in steps of 4. So starting with 1, then 5, etc. 4 loops then. So 4 loops are already mentioned in the previous meeting, but we'll do a little recap again today, because 4 loops are a very important part of what we try to teach you. We say a for loop because it's a loop. It runs from the keyword for up to the end that belongs to the keyword. If you select one of the keywords, it will show with a little line the corresponding other. So if I click on 4, there is a little line beneath this end because it wants to show me which end belongs to the 4. In this case, it's very clear because I indented the full block. After 4, it says the name of a variable. Usually, you could use any variable that you want. So you could just call it number or number, for instance. But in this type of simple iterations, I or X or Y are usually the single letter variable names that are used. I is I for iterator. The value of I within the loop is always one of the elements of my number because of this statement. So at the first time it goes through this loop, I will have number 1 because that's the first element of the my number vector. The second time it will be 2, etc. If my numbers would be 4 up to 1, it would start with 4, then 3, then 2, then 1. So it starts with the first value of my numbers and it ends with the last value of my number. Within this block, a new variable is being named A, which is again a vector. You can see it's a vector because it has round brackets. And the first element will be 20 plus 1 the first time. It will show the value of the full vector of A, and then it will pause for a second so that we can see what it's doing. And then it repeats because it reaches the keyword end, so it goes back to the 4, and the second value of my numbers is the current value of I. So in this case, that means that the I now has a value of 2. So the second value of A will be 22, etc. So if we run this code, I would expect that this code prints out first the number 21, then the number 21 and 22, then the number 21, 22, 23, and then 21, 22, 23, 24. That's what I would expect. So let's see what happens. 21. Okay, so we can see the factor A growing for each iteration. These growing factors, as we see in this case, they grow because the value of I in this statement is always a bit larger than the size of the current vector A. So you assign a value to the next value that A could have. A way to address, to find the value of the last element of A would be to just ask for the length of A, but MATLAB has the convenience variable AND available in this case, in which you can ask for the last value in the vector A by just putting their AND in there. So if you do that, you can see the last value is 24. This also enables you to write something to a bit further than the end by expressing AND plus 1. If you do that, you can see that A grows again. It's one larger than it was before because I assigned a value to a space in A that wasn't available before. You can even go further than just the last or just one past the last. You could specify an index that does not exist. For instance, number 12, which is far further than the end. What MATLAB does then, I now assign the value -1 to the 12th element in A. If I do that, it will fill in all the remaining numbers with zeros. That is very important to realize because that is behavior that you might not expect. So it's very important to realize that the numbers that the variable I can get are defined after the equals statement in the for statement. And the right-hand side part of the for statement is actually a vector. So for I is, and then just stating a vector like 1 up to 4 is also valid. So this code also runs and does in principle the same as the previous version did. In this case, you can see that because the variable A already existed, it will change the numbers into the numbers that it already had. So if I delete factor A by saying delete here, and then run the code again, you can see that it does the same as the code did before. So the for statement, as mentioned before, is what we call predetermined looping, because the values that are used within a for loop determine the number of loops that the statement will make. So there is also a second type of statement which is called conditional looping, and that's the while statement. While statement also has the same setup as for. It is, but instead of the keyword for, you use the keyword while, and then you put in a condition, and between the while and the corresponding end, there's a block of code that will be repeatedly run until the condition is no longer true. So how does that work? Well, it's simpler than the for loop. So between the round parentheses of while, it has a comparison. So this could be true or false. And while the value of a is smaller than 10, a will be a plus 1.5, and it will display the value of a. So that means because this is a comparison, the variable a must exist before it enters the while loop. So that's why we start with a value of 0 here. If you run this, you can see that the value of a is the value that is displayed is 1.5, then 3, 4.5, 6, 7.5, 9, and then 10.5. So that is the moment, at the moment the value is 10.5, is the moment that it is no longer smaller than 10. So that is the moment it breaks from the while loop. You could also do it another way. You could also say while, and then say while is true. So this condition will always be true, so you enter into an endless loop. But because in this statement I say if a is larger than 7 break, we break out of this loop after a is becoming larger than 7. So you could leave out this a here. No, you could not, because you need a for the a plus. So this is a different way of creating a end of the loop by entering the break statement. So if we run this, you can see it does the same. The only difference is that I now break when a is larger than 7 instead of when a is larger than 10. One thing that we didn't really mention before, but that is because for anyone who programs it might seem a bit obvious, is that blocks and loops can be combined, and you can have blocks within blocks within blocks. So for instance here, different loops and conditionals can be combined, as I did here. This is a while block, so you can see that if I click on while, that it belongs to this end. So this part of the code will be repeated until a is smaller, is larger or equal to 10. And there's an if block in there, but there could also be a for loop in there. In this case, it will display the value of a, and if a is between 4 and 9, it will show a different statement than when it is not. So if we run this code, it will repeat until a is no longer smaller than 10, and that is when it's 10. And when it's 10, it's not between 4 and 8, but 5.5, 7, and 8.5, they are between 7 and 8. So you can have blocks in blocks and blocks and blocks, etc. So we call this conditional looping, and we call it conditional looping because we don't really know how many times the loop will be run through. An example where that becomes apparent is the next example, where we try to throw a dice, and of course we throw a dice with 10 different possible numbers. And we try to find out whether it is my lucky number, and my lucky number is number 7. So we're going to throw a dice while lucky number 7 is not 7. So we repeat throwing a dice until my lucky number 7 comes up. What I do in the loop is first I really throw a dice. I do that with the statement randy. We saw that before. So we have a random scalar between 0 and 10. So random number 7 is a random number between 0 and 10. If it is number 7, then we display, yay, I've got my lucky number 7. And if not, we say, it was another number. Because of the fact that the while loop runs until number 7 is drawn, it will stop after the yay it was. Another way to do that is by saying while true, and then after the display yay it was, say break, as is obvious from the previous example. So let's see what this function does by pressing F9. So you can see that it did actually needed to roll quite a long time before it rolled my lucky number 7. And what you can see if you run it again is that it will run different amounts of throws every time, because it is the random number 7 occurs once every so many times, but it's a random number. So up to now we've been working in MATLAB with what we call scripts. So we write code and we put it in a text file, and this text file just has the things we want our program to do in a sequence underneath each other. We learned a little bit about code reuse in loops, so we were able to do the same thing several times in a row without having to rewrite the code every time with different values. A better, more generic, and maybe the preferred way to do this more generally is the use of functions. That is the main part of the rest of this talk. We have been using functions up to now by calling them, like for instance the Randy function that we used in the previous assignment is a function. And a function is defined in a file which has the same name as the function. So if you're interested in creating your own functions, you can do that by clicking New, a little triangle underneath New, and then say Function. If you open a function, it creates a new function for you which still has no name. In this case it's called Untitled3, because I also already have 2 Untitles somewhere in my system. And it creates the basic building blocks for creating a function. I will try to explain a bit more about how functions work by closing this one and opening the circlearea.m file, which is also in the code that belongs to this in-class assignment. So I don't want to save this, and I go to the circle area. You can see that the basic way that this function is written is the same as the example that you get when you open a new one. In this case, it starts with the keyword function and it ends with the keyword end. The last end is optional, but I urge you to always end a function with end. The reason it is optional is because the end of the file implies the end of the function. In this case, the function is called circle area, and what it does is it calculates the area of a circle given a certain radius. So the parameter, the only value it needs to have to be able to calculate the area of a circle is its radius. So I tell the function by putting the r here that I want a variable named r in my function that when this function is called will hold the radius of the function. And in front of the equal sign there is another variable that I define in the function call, and that's called area. And area is the output of the calculation. So at the end of the function, when the function is ready calculating, the value area is returned to the main program. Underneath the function definition, there's a block here with percent signs in front of them. And we know what that means. That means this is comments. In the case of a function, it has a special meaning because it's also the place where you can define the help text. So if you write it similar to this, if I then in my command window would type help circle area, it will print out this text. So that's very handy. So, and I would urge you to write something there, at least to make it to make your code readable for other people. The full calculation in this this atypical function is area is pi times r squared, because that's the definition of a of the area of a function of a circle. Sorry. So it's a very simple function. You would easily do this without a function. But so you can see that the full code is, in principle, fully self-contained. So the only variables that are used in the code are area and r. Pi is a constant of MATLAB, and this is just a calculation. So within the function, it needs no other information than that it gets through its input argument, and it has no other output than its output argument. I'm going to show you a tip now on how to debug, but also get some information about what really happens within a function. So what I'm going to do is you can see next to the line number 9, there's this minus sign. If you click that, you will see a red circle appearing. We call that a stop point, a break point. What happens is when you call this function now, MATLAB will hold execution when it reaches this code and will allow you to evaluate all the information of the state of the function. So if I call the function, let's first define some random data. Say 1, 2, 3, 4. Oh, sorry, data is 1, 2, 3, 4. So we have some variable in our workspace. Now I'm going to call the function circle area as my area. My area is circle area of a circle with a radius of 5, and you can see that next to the round circle, the red circle, an arrow occurs. And you can see that area is pi times is not yet evaluated, but you can also see that the workspace has changed. So the data variable is no longer visible here. So within the function circle area, MATLAB knows nothing about the data variable that we had in our main workspace before. It does know about the variable r, which I did not specify in my call, only the number was specified. But within the function, this number is the value of the variable r. If I press continue, the function will continue. And you can see it goes on. It gives you the result because I did not put a semicolon behind my call, so it replies with 78. And you can see that next to the variable my area, so not area, but my area, because I created the variable here. So the value of area is now in my area, and it's the value of data is, it reappeared because I'm back into my main workspace. So if you don't have circle area open yet, you can type edit circle area, like this, in your command window, and it will open the editor with the correct value of the correct file. If you type help circle area, you get the help text, and help text is the text just following the keyword function in commands. You can call the function without catching the variable by just typing it. Oh, sorry, I just had the breakpoint on still, so I'll continue. Then the value will go into the variable ons, as we've seen before. You can put variables inside of the call, of course. So you can say radius is 5 and then call circle area with radius, and that will give you the same result as entering 5 there, which you can see here. So radius is 5, and now area is again the same. You can also do things, of course, you can do things like this, like specifying the diameter and then calling circle area with diameter divided by 2, because the diameter is twice the radius. And what happens when you do this? You can calculate a radius from some nonsense values, but it has to be, of course, it has to be a single value in this case. So this is how you create your own functions. Functions need to be saved somewhere where MATLAB can find them, and they have to have the same name. The file needs to be the same name as the name of the function. So that is very important. If it is different, even with just a capital difference or something like that, it will not be able to find it. So make sure you realize that. There's a second thing that MATLAB that makes MATLAB a bit special in this case, and that is that you call a function using the parentheses. And we used the parentheses before in the indexing, and you can see that if I have a variable, if I say I have a variable named circle area, and I create a vector. So now I have a totally legal MATLAB code. I say I have a variable circle area and it has 5 numbers in there. If I now ask for the 5th element of circle area, it will say 5. So it will not calculate the circle area based on the R, because it first finds a variable with the same name. This is very important to realize. So most programming languages have different characters for indexing and for calling a function. So you have this, in most languages you have the square brackets for indexing in variables, in vectors and matrices. MATLAB uses the round, I always say round brackets, it's the parentheses. And that could lead to confusion. So be aware of that. Don't call your variables with a name that it's also a function, because if you do, you will not be able to call the function anymore. That's it for today. I hope you have a nice in-class assignment together, and have fun.